Hello there, dear viewers. Welcome to another installment of the iBet Show. I'm Ivan, reporting from Forward Base. Today on the table we have this. This is a electronic handbrake module from a Land Rover Discovery, which I obtained. So what this thing does is, as you can see, it has these two cables coming out of either side. And by some mechanism, which we're going to explore in a moment, this servo motor pulls them in from both directions. So the electronic connector is here. Is this board, which you're going to see what it does, and then you get the servo. Which is most likely a gearbox, as well as this down here, which I found out is a safety release cable. Because in fact these fail quite a lot, and which is why this one was thrown out. So it's actually lobe-sided. It pulls one of them in more than the other. So yeah, we're going to take these out. Got a few torques in here which we're going to try to remove, and then we're going to see what we can do to get it out. So I think first what I'm going to do is I'm going to disconnect these from the board. Actually no, I might leave this one. I'm going to unplug these there. Okay, so these are now disconnected. You got this, well, basically what looks like a fat flex cable. And yeah, now we can start thinking about getting these screws out. So there's this one, which right, so I've got this out and it's swimming in grease, so I decided to put a piece of paper underneath. So let's see what we have here. So we have these cables protruding either side. This can slide back and forth. It doesn't look like there's actually any facility to move this shaft along the gearbox, which is strange. We have this. I think this is the catch. Oh, oops. So that's what that is. So this is one connection from one cable, and on the other side we have this. Now, what I was going to say is that I think this is the safety release, which it might have been because, well, it allowed us to remove this part. Which, let's see what it says. It's just some kind of code I don't recognize. So that's one end. The other end, which doesn't look like we're able to remove right away. So probably the best way to go about this is, in fact the only way I see to go about this would be to take the gearbox apart, which we need a different Torx bit for. Hang on. Problematic shortage of hands. Now let's see what's in here. So this is just a bearing. I think that's what they call a shielded bearing. Yep, double shielded, good. And in here are some gears, some plastic gears here, which are working with this, which is on the servo motor. And in fact, what that does is pull this shaft along. It rotates it. So if you look here, if I turn this gear, it turns the shaft, which I don't know why that's beneficial. We're kind of in a state of baffledness here. So if we put this into perspective, what that would have done is, when this motor was actuated, it would have turned the shaft and basically twisted the cables, which I'm not sure why that would have been beneficial. Maybe taking this part apart at a later date will reveal more about that. I have been doing some more thinking and doing and all of that, and I think I have cracked about all the secrets that there are to crack about this. First of all, I have discovered how this thing actually generates the tensile force. So basically, through this gearbox, it is possible to rotate this part. And that, as you can see, will pull in this thread. Now this thread was all seized up and locked before. I had to use quite a bit of force to discover it. Interestingly enough, it is actually I think it's called right-hand thread, so it's opposite to what's commonly used. And that combined with this square section here at the end, which cannot rotate, can move the wires back and forth. I have in fact also counted that this this gearbox has a gear ratio of 1 to 12, so as in it steps the RPMs down by a factor of 12, so 1/12 of the input comes onto here. On which topic I have discovered about this motor that it is in fact indexing. It indexes every 30 degrees, so it has 12 positions for a full rotation. This part. Now, this is the part that locked into here, remember? Is the lid. And basically what it is a Newton meter. So it measures how much tensile force there is. So this is the other end of the wire. It just comes off like this. It had this plastic retaining ring, which I took off. So what happens in here is this is just the anchor. So these two are not mechanically connected here. This is the anchor which locks into this part, which can be released by the safety release, I guess, which is now currently upside down. So this locks in, this is just the anchor, and this locks into the wire here with this. What happens is, as you put more and more tensile force on the wire, it pulls this end outwards, thus compressing this pretty beefy spring, certainly more than I can compress with my hands, which is then connected to this little plastic ring which has a magnet in the top. So this little thing here is a fairly strong magnet. I think it's probably a neodymium or something like that. And then there's a detector on the top here, which is where the fat flex connects to, and that detects the movement of the magnet in front of it, and from that the computer can then calculate how much force is actually on the handbrake, which then connects to the board, which is probably why there is so much stuff on here, because it needs to count and calculate and stuff, which is quite unfortunate for us, because it's difficult to discern which of this is brains and which of it is the driver circuit for this, because obviously in its current form this is pretty useless hunk of metal. We're going to have to figure out how to drive it first before we can use it for anything useful. And I think this, in fact, once we've figured out how to use this fat flex for anything useful, we're going to just leave this as is and use it as a Newton meter in some future experiment. So yeah, I think that's with that all the secrets that there are to crack in this module have been cracked. So I thank you once again for watching, and stay tuned for later projects on our channel.